Yes. Hello friends. Welcome to the session. Myself Surendra. The subject is electrical and electronic measurements. Okay. Before starting according to syllabus, I want to give some introduction regarding to this subject. No doubt at all. This is also an important subject for any competitive point of view. Okay, with respect to different competitive exams, first I want to give what is the weightage we can expect in electrical and electronic measurements. For gate point of view, the expected weightage in gate exam based on this measurement subject is we can expect 4 to 5 marks, but it is not constant. It may be plus or minus 1 mark. Okay, but as for previous weightage, I am giving this 4 to 5 marks we can expect for gate point of view. Then come to the another exam. In engineering service exams, both objective and descriptive. For objective point of view, the expected weightage is, here I am giving the number of questions. We can expect 12 to 15 questions. For descriptive point of view, the expected weightage is, we can expect 35 to 40 marks. Okay. Then any other PSUs, mainly you take any state government jobs, other PSUs, either state or central government jobs, the expected weightage is 6 to 8 marks we can expect, but it is not constant. It may be plus or minus. Okay. Mainly you concentrate on gate and ESC, and other PSUs also, the minimum weightage we can expect from the measurement subject. Then what are the reference books for electrical and electronic measurements is, so many books are there. What are the reference books you follow? One is electrical and electronic measurements and instrumentation by A.K. Shahani. This one good book, no doubt at all. Electrical and electronic measurements and instrumentation by A.K. Shahani. The another book is electronic measurements and instrumentation by David A. Bell. This also important book to solve the variety of problems. Okay. Then another one is electronic measurements and instrumentation by H.S. Kelsey. So many books also there for reference, but mainly concentrate on electrical and electronic measurements and instrumentation by A.K. Shahani. Then during preparing this subject, mainly follow the classroom explanation and you solve the classroom workbook problems and you solve previous gate and IS questions. That preparation is enough for any competitive exam, either gate or ESC or any PSUs. That preparation is enough. What I am telling, regularly follow the classroom explanation and you follow the classroom workbook, whatever you are solving, and whatever our ISWA Institute will providing, then student workbook also, that you practice and you solve the previous gate and IS questions. Okay. Our institute will providing with solutions, gate and IS questions with solutions it is providing, that you practice. That preparation is enough for any competitive point of view. Okay. Then come to the subject. In total electrical and electronic measurements, the concepts I want to discuss. First I will start with some introduction. I will start with some introduction. Then first chapter is, I will start with the concept of measurement system. This is the first chapter, concept of measurement system. Yes, in the concept of measurement system, I will discuss, mainly I will concentrate on methods of measurement, this one concept I will discuss, and I will explain what are the different types of instruments. The next concept is characteristics of instruments. Okay. Under chapter 1, I will cover all these concepts. I will explain the measurement system, that is what the block diagram of measurement system. Then I will explain what is the different methods of measurement. Then I will discuss the types of instruments and characteristics of instrument. Yes. Then go for second chapter. This is very important for any competitive point of view. That is, I will start with error analysis. This very important concept for GATE and engineering service examinations point of view. This error analysis is very important concept. In second chapter, I will cover what is the concept under error analysis. Then under the third chapter, I will start with the basic requirements of indicating type instrument. And this is the fundamental concept for different types of instrument. By understanding this concept only, then we can clearly understand different types of instrument. That is basic requirements of indicating type instruments. Basic requirements of indicating type instruments. Basic requirements of indicating type instruments. This is one concept, and this is the fundamental concept for all the instruments. Then fourth one is this very important. I will discuss PMMC, permanent magnet moving coil instrument. Then MI, moving iron instrument. Electrodynamometer, or it is also called electromagnet moving coil type instrument. Electromagnet moving coil instrument. Then PMMC EDM, electrodynamometer or electromagnet moving coil type instrument. Rectifier type instruments. Then amplifier type instrument. Then thermal instruments. Yes. Induction instruments. And electrostatic voltmeter. Electrostatic instrument. Mainly under chapter 4, all these concepts I want to cover. Different types of instruments I want to discuss. Permanent magnet moving coil instrument, moving iron instrument, electrodynamometer or electromagnet moving coil type instrument, rectifier type instruments, amplifier type instruments, thermal instruments, induction instrument, electrostatic voltmeter. Point to remember, all these concepts comes under measurement of voltage and current. That means in most of all the competitive exams, in the syllabus, they don't mention all these instruments. Simply they are giving the statement like this: measurement of voltage and current. That means we are studying the measurement of voltage and current means we want to study all these instruments with respect to measurement of voltage and current. That is the meaning. Understood? They don't mention PMMC, MI, EDM, rectifier type instrument, amplifier type instrument, like that they don't mention. Simply they are giving the statement is, even in the gate syllabus also, they are giving the statement measurement of voltage and current. Measurement of voltage and current means all these concepts we want to study. Okay. This comes under chapter 4. Under chapter 5, power measurement. This very important concept, power measurement. I want to discuss power measurement. This comes under study of wattmeters, power measurement. Then under chapter 6, I want to discuss energy meter, okay, energy meter. Then potentiometer, Q meter, quality factor meter, power factor meter. Then I want to discuss frequency meter. Then CT and PT, that is the instrument transformer, current transformer and potential transformer. All these concepts I will cover under chapter 6. Energy meter, potentiometer, Q meter, quality factor meter, power factor meter, frequency meter, CT and PT, current transformer and potential transformer. This is very important concept for gate point of view or any other competitive point of view also. Even potentiometer is also very important concept, gate and other competitive point of view. And CT, PT is also very important concept. Instrument transformers is also very important. This is under chapter 6. Then under chapter 7, I will discuss AC and DC bridges. This concept comes under measurement of inductance, capacitance, frequency and resistance. Okay, in detail about AC and DC bridges I want to discuss. Then under chapter 8, I want to discuss electronic instrument, that is CRO, digital voltmeters. CRO and digital voltmeters. Okay, these are the total measurement, electrical and electronic measurements. I am dividing into 8 chapters. Okay, I will start with some measurement system, error analysis, this basic requirements of indicating type instrument. This comes under measurement of voltage and current. Then power measurement, energy measurement, potentiometer, Q meter, power factor meter, frequency meter, CT and PT. Then chapter 7 is AC and DC bridges. Chapter 8 is CRO and digital voltmeters. Okay, this comes under electronic measurement. Up to this total comes under electrical measurement, except rectifier type instruments, amplifier type instrument, then this rectifier type, amplifier type instrument, and there is a combination of rectifier amplifier and amplifier rectifier type instruments also there, that also I will discuss. Okay, these are the different concepts. For any competitive point of view, this is the syllabus in electrical and electronic measurements. But in some competitive exams, some PSUs, in state government jobs or even under central governments also, and in ESC exam also, there is one more concept is also there, transducers. But that is a separate subject. But I am discussing electrical and electronic measurements. Okay, this is the syllabus for electrical and electronic measurements for any competitive point of view. Okay, first I will start with some introduction. Then later on you go for the first chapter, that is measurement system. Clear? Okay, note down quick. Here you want to one more book that is also there, electrical and electronic measurements and instrumentation by R.K. Rajput. Okay, no need to refer all these books. This book is enough. You follow my classroom explanation, solve classroom workbook, solve our institute student workbook, and you will solve our institute which are providing previous GATE and IS questions. Then you can solve the previous GATE and IS questions. That preparation is enough maximum. Okay. Then we'll start with some introduction. Yes, tell me. Can you define what is the measurement? Can you say that what is the measurement? Yes. Listen please. So many definitions are there. Here I want to give two definitions for measurement by using two examples. For example, I want to measure length of this board. If you want to measure length of this board means what you can do? You can take either tape or scale, then we can measure the length. Then after measuring the length, then we can say like this na, it is 2 meters, it is 1 meter, it is 500 centimeters, it is 200 centimeters, like that we can say. But we cannot say like this na, it is 1, it is 2, it is 3, it is 100, it is 300, like that we cannot say. We are telling that in terms of meters or centimeters. What is this meters and centimeters or kilometers? Yes, standard quantities. That is the standard units. Okay. Similarly, if you want to measure, just example I am telling here. If you want to measure weight of any unknown quantity, what you are doing? You take balance. In one side we can add the unknown quantity. In another side we can add the standard quantity. Whenever this unknown quantity is equal to standard quantity, then finally we can say like this. It is 1 kg, it is 100 grams, it is 200 grams, it is 3 kg, it is 4 kg, like that we can say. Yes or no? But we cannot say like this na, it is 1, it is 200, it is 3, like that we cannot say. We are telling in terms of grams and kilograms. What is grams and kilograms? Standard units. Then based on these two examples, I am giving two definitions. According to first example, one of the definition of measurement is, it is a process of conversion of a physical parameter into meaningful number. Yes or no? It is a process of conversion of a physical parameter into meaningful number. Length is the one physical quantity. We are telling length in terms of standard quantities. 200 centimeters, 1 meter, 300 meter, like that we can say. That means it is the process of conversion of a physical parameter into meaningful number. That is called measurement. According to second example, unknown quantity, standard quantity. Then according to second example, how to define? Yes. It is the process of comparison of unknown quantity with the standard quantity. Unknown quantity with the standard quantity. And the resultant is in terms of standard quantity. Yes or no? It is the process of comparison of unknown quantity with the standard quantity, and the resultant is in terms of standard quantity. Okay, this is also called measurement. But point to remember, for every measurement, measurement of length, measurement of weight, in every measurement is the process. Whatever the measurement we are doing, that is one process. I am measuring the length, I am measuring the weight, I am measuring the resistance, I am measuring the voltage, I am measuring the current. Whatever the measurement we are doing, that measurement is the one process. For every measurement process, we can use one device or instrument. That is called measuring instrument. Yes or no? If you want to measure the length means we are using the tape. That is one measuring instrument. If you want to measure the weight means we are using one balance. That is one instrument. If you want to measure the resistance means we can use one ohm meter. We can use one Wheatstone bridge. Then that is one instrument. If you want to measure the voltage means we can measure the voltmeter. Like that. Measurement is the process. For every process we can use one device or instrument. That is nothing but a measuring instrument. But point to remember, science and technology is unending chain. If science and technology is unending chain means every day, every minute, a new phenomena will be developed. Whenever new phenomena are developed, In order to make the relations in new phenomena, a new sophisticated measurement system is required. Yes or no? That means if there is a science and technology, there is a measurement system. That's why science and technology is unending chain. That's why measurement system is also unending chain. What do you mean by measurement system? Measurement is a process. For every process we are using instrument. The combination of measurement plus instrument is nothing but a measurement system. Then our syllabus will be started from measurement system. Clear? Okay. First you write what is the definition of measurement. Write down first definition. Quick, note down, write down. It is a process of conversion of a physical parameter into meaningful number. A physical parameter into meaningful number. Process of conversion of a physical parameter into meaningful number. Yes. Or another definition. Or another definition you write. Okay. It is a process of comparison of unknown quantity with the standard quantity. Unknown quantity with the standard quantity. And the resultant is in terms of standard quantity. And the resultant is in terms of standard quantity. Yes. Write down one more point. Continuation. One more point to write. Measurement is the process. Measurement is the process. For this process, one of the instrument is used. For this process, one of the instrument is used. Then it is called measuring instrument. It is called measuring instrument. It is called measuring instrument. Then, write down, therefore measurement plus instrument. Write down, measurement plus instrument is nothing but a measurement system. Measurement plus instrument is nothing but a measurement system. Now put siding. Chapter 1 is measurement system. Therefore, measurement plus instrument. Measurement plus instrument. It's nothing but a measurement system. It may be simple measurement system or it may be complicated measurement system. That depends on type of measurement we are doing and type of instrument we are using. Yes sir. If it is a complicated measurement system means whatever the measurement we are doing, it may be complicated, or whatever the instrument we are using, it may be complicated instrument. That's why based on the type of measurement doing, based on the type of instrument we are using, it may be simple measurement system or it may be a complicated measurement system. Okay. Now let's see what is the block diagram representation of measurement system. Under chapter 1, this is the first concept. Block diagram of measurement system. Block diagram of measurement system. Yes. All of you note down this. Parallelly draw this block diagram. Don't wait. For the block diagram of measurement system. Yes. At input side, it consists of, in a measurement system, it consists of transducer. It consists of one transducer. This input is physical quantity. The input is physical quantity. Yes, what the physical quantity means? It may be force, pressure, flow, velocity. All these are the physical quantities. Internally, a transducer consists of, transducer is nothing but a combination of primary sensing element plus transduction element. What is primary sensing? What is the transduction element? That I will discuss. That means in a measurement system, the starting block is transducer. In the transducer, first is primary sensing element, next one is transduction element. Then the output of the transducer is given to signal conditioning circuit. Signal conditioning circuit. This is given to signal conditioning circuit. Signal conditioning circuit. Yes. Then the output of the signal conditioning circuit is given to variable conversion element. This is given to variable conversion element. Variable conversion element. Don't wait. Parallelly note down this block diagram. Then output of the variable conversion element is given to variable manipulation element. Variable manipulation element. Variable manipulation element. Variable manipulation element. Okay. The output of the variable manipulation element is given to data transmission element. Data transmission. Data transmission element. Then the output of the data transmission element is given to data presentation element. The data presentation elements are, it may be, this is DPE, data presentation elements. This is instruments, indicating instruments. Indicating instruments. It may be recorders, or it may be CRO, or it may be digital voltmeters. Okay. This is a block diagram representation of a measurement system. It consists of transducer, signal conditioning circuit, variable conversion element VCE, variable manipulation element VME, data transmission element DTE, data presentation element. Okay, tell me, what is the purpose of using transducer? We know that the general definition of transducer means which converts, generally which converts one form of energy to another form of energy. One form of energy to another form of energy. Another form of energy. Okay, this is nothing but a transducer. Generally, a transducer is defined like this. But here, internally, a transducer consists of primary sensing element and transduction element. What is the purpose of using primary sensing element? What is the purpose of using primary sensing element? It's just like a sensor. It senses the physical quantity. It senses the physical quantity. It senses the physical quantity. Physical quantity. Physical quantity. Yes. That means, for example, to sense the force, to sense the pressure, to sense the flow, to sense the velocity, all these are sensed by primary sensing element. That means it senses the physical quantity and it converts physical quantity into mechanical displacement. Physical quantity into mechanical displacement. Which converts physical quantity into mechanical displacement. One of the example of primary sensing element is, for example, take the Bourdon tube is one of the example of primary sensing element. Bellows, capsules, all these are the examples of primary sensing element. Yes or no? For example, you take the Bourdon tube. What the Bourdon tube can do? Yes. Take the example of Bourdon tube. Then what it can do? When you apply the pressure, whenever pressure is applied to the Bourdon tube, when the pressure is applied, there is some mechanical displacement. This is fixed end. One end is fixed end. The another end is movable. That means whenever pressure is applied, whenever force is applied, because of this pressure or force, then there is a displacement at another end. That means we are converting a pressure into mechanical displacement. That is nothing but a primary sensing element. Understood? But point to remember, this primary sensing element acts as a mechanical transducer. That point also remember. It acts as a mechanical transducer or primary transducer. Mechanical transducer. Just introduction I am giving. Transducer or primary transducer. Primary transducer. What do you mean by mechanical transducer or primary transducer means? Yes. The transducer, mechanical transducer means which converts physical quantity into mechanical displacement. Primary transducer is also called which converts physical quantity into mechanical displacement. That's the reason why a primary sensing element acts as a mechanical transducer or primary transducer. Clear? Transducer, generally transducer means one form to another form. But individually we are defining what is a mechanical transducer, what is the electrical transducer here. What the mechanical transducer means, which converts a physical quantity into mechanical displacement. That is also called primary transducer. Okay, that is the purpose of using primary sensing element. Then what is the purpose of using transduction element? Transduction, TSE, transduction element. What is the purpose of using transduction element? Yes. That means from primary sensing element, we are getting the output is which one? Mechanical displacement. That mechanical displacement is applied to which one? Transduction element. Then what this transduction element can do means, which converts a mechanical displacement into electrical quantity. That means which converts mechanical displacement into electrical quantity. Mechanical displacement into electrical quantity. Electrical quantity. Okay, that is nothing but a transduction element. That's the reason why, which converting mechanical to electrical that's the reason why it is acts as an electrical transducer. It acts as an electrical transducer. Or it is also called acts as a secondary transducer. Secondary transducer. Secondary transducer. Okay, that is what is the purpose of transduction element. Generally, how to define electrical transducer? Here, mainly we are talking about electrical output now. That's why we are talking about electrical transducer means which converts mechanical displacement into electrical. That is called electrical transducer. If any system converts electrical to mechanical, then that is called inverse transducer. Point to remember. Generally, transducer means you take the electrical transducer which converts mechanical to electrical. If any system will convert electrical to mechanical means then opposite to this process now, then that is nothing but an inverse transducer. Okay, leave it. Then this is about transduction element. Then what is the example of transduction element is? Take the example of LVDT. For example, this is primary sensing element. Here I am connecting on LVDT. This is primary of LVDT and this is secondary of LVDT. We know that LVDT consists of 2 seconds. In detail about that you will see in your transducer subject only, but no need. This is LVDT is having 2 secondaries and these 2 secondaries are connected in series opposition to get the differential output. Then in between we are placing the one core. Then this core movement is connected to the primary transducer. Core movement is connected to primary. Whenever pressure is applied, because of this pressure, there is a displacement in the one end of the Bourdon tube. Because of this displacement, the core position will be changes. Once the core position is changes, whatever the output voltage induced in the secondary winding, the output voltage is also changing. That means core movement is changing, that is nothing but a mechanical displacement. This mechanical displacement is converted into change in mechanical displacement is converted into electrical output. Then it acts as a which element? Transduction element, or it is a secondary transducer, LVDT, linear variable differential transformer. Clear? Yeah, this about what exactly? Transduction element. Okay, this is the block with respect to transducer. Now, the output of the transducer is given to the signal conditioning circuit. What the signal conditioning circuit can do means, it measures the output of the transducer in terms of electrical quantity. In terms of electrical quantity means it measures in terms of voltage or it measures in terms of current. One of the example of signal conditioning circuit is AC and DC bridges. AC and DC bridges are used as a signal conditioning circuits. And potential divider circuits also. Potential divider circuit is also used as a signal conditioning circuit. Take one example. For example, in the measurement of strain by using strain gauge, what you can do means a strain gauge can do, a strain is converted into change of resistance. That change of resistance we can connect one of the arm of the bridge. This is you take the DC bridge. In one of the arm of the bridge, I connected strain gauge. Okay, let initially the bridge is balanced. Let assume that initially the bridge is balanced. Whenever strain is applied to the strain gauge, then the resistance of the strain gauge will be changes. Then bridge is unbalanced. Because of unbalanced, there is a current through galvanometer, there is a voltage across the galvanometer. That means we are converting change of resistance into electrical output, either voltage or current. Then this acts as a signal conditioning circuit. In that application, we are using this signal conditioning circuit. We want to represent the output of the transducer is in the form of voltage or current. Yes, sir. Because we want to transfer means, mainly we can transfer which quantity? Current only transfer, not the voltage. We can transfer the current. Now we are getting in terms of voltage. Then again that voltage we want to convert into current. Then we go for the variable conversion elements. Then whatever the output of the signal conditioning circuit is there, that is applied to variable conversion element. It is applied to the variable conversion element. Now tell me, whenever it is applied to variable conversion element, then based on the requirement, this variable conversion element will may convert analog to digital, or it may convert digital to analog, or it may be I to V converter, or it may be V to I converters. All these are used in the variable conversion elements. For example, I want to data in the form of digital, but available output of signal conditioning circuit is analog. Then what you can do? We can use analog to digital converter. But I want data in the form of analog, but available signal at the signal conditioning circuit is digital. Then we want to convert digital to analog. Like this, we are using the variable conversion element. Then what is the variable manipulation element? The output of the variable conversion element is given to the variable manipulation element. What the variable manipulation element can do means, it changes the, whatever the output we are getting from variable conversion element, it changes the electrical quantity. It may changes amplitude, or it may amplifies the signal, or it may be attenuates the signal based on our requirement. That means, which are used as a variable manipulation element? Amplifiers are used as a variable manipulation element. Amplifiers. And it may also consist of attenuators to change the amplitude without affecting frequency. Attenuators. Okay. Then we can use variable manipulation element. Then whatever the variable manipulation element output is there, that is given to the data transmission element. This data transmission element, mainly transmission network we can use. Okay. Or if you want to transmit the signal for very long distance, then we can use some transmission lines, or we can use some satellite arrangements also in order to transmit the signal. Okay, this is the data transmission element. Then if you don't want to transmit, just it is given to the data presentation element means, then it can measure. For example, if you want to measure the data, you want to measure the voltage, you want to measure the current, the data presentation element is voltmeters and ammeters. Then if you want to record the data, then data presentation element is recorders. If you want to measure the waveform, you want to see the waveform, you want to analyze the waveform, then you want to see the output, you want to analyze the output, then data presentation element is CRO. If the data is in the form of digital, then data presentation element is digital voltmeter. Like that we can use. Okay, this about what exactly measurement system. Clear? Concentrate. Okay, this about what the block diagram representation of measurement system. Okay, transducer, signal conditioning circuit, variable conversion element, variable manipulation element, data transmission element. But in detail about this block, we will study in transducers concept. Okay, about signal conditioning circuits, mainly in the AC and DC bridges, are the sum of the signal conditioning circuit. Potential divider arrangements also signal conditioning circuit, that we will see in our electrical and electronic measurements. Some blocks of signal conditioning circuits we will see in our electrical and electronic measurement. Variable manipulation elements we already studied in digital and analog subject. This variable conversion and variable manipulation element you already studied in digital and analog subject. Data transmission elements you already studied, but data presentation element, indicating type instrument, CRO, digital voltmeters, all these we will see in our measurement subject only. I am explaining electrical and electronic measurement means mainly we are concentrating on data presentation element and some part of signal conditioning circuits. Clear? Okay. Now we'll see in detail about that. Then before going to the different instruments we are using in the data presentation element, first I want to discuss, I told already, measurement system is nothing but a combination of measurement plus instrument. Now I want to discuss what are the different types of measurement methods. Then after that I want to discuss what are the different types of instruments. Okay. We'll continue with just to take 5 to 10 minutes break, then we will continue with in the next session what are the methods of measurements, what are the types of instruments in the same measurement system only. Okay.